Alright, good evening everyone. I hope that you have had a wonderful day. Tonight we are going to discuss function failure identification and propagation, otherwise known as FFIP. So what this analysis does is it identifies a failure within the system and tracks it through the functional model. And for those of you who are not familiar with what a functional model is, basically what it is a very generalized flowchart of how the system functions. So in this case, again, I am analyzing the lathe subsystem of the makerspace system. If there was a loss of external energy, or external electrical energy, this failure would be passed through the divide. Basically, this is a fuse bus or breaker panel, anything to divide the electrical power into the sensing system as well as the motor system. So this loss of power would pass, for example, down the regulate path, and once it gets to the convert stage, which is the motor, so it's converting the electrical energy into rotational mechanical energy, that will fail. It is then passed into the coupling stage. This is where the lathe jaws are gripping the material, and passed through the mixing of the liquid material. This is the coolant or cutting fluid. And finally, it goes into the remove section. This is the actual cutting, and that will fail because the spindle is not spinning, and therefore it can't cut, and bad things happen. So these outputs here are also failed because they will not be produced. However, the liquid material will likely still be there and be causing a mess. So that output is still fine. Up here, the failures pass through the divide and into the sensing system. Both of them, actually. This one is for the rotational speed of the spindle, and this one is for the position of the translational axes. And each of those would fail because they would not be able to sense the position without a external power source. Then the failures passed into the convert section. This is basically just a PLC or whatever they use to control the digital readout. And then because there would not be a electrical signal passed to the display, that would also be failed, and the output of a visual status to the operator would also fail. Here we have a loss of coolant failure. So coolant is not coming into the system, therefore the mix section cannot happen. The failure is passed into the remove section, which could potentially fail if the tool or the part gets too hot and ends up shattering. But one thing that it will for sure do is it will be passed down and fail the liquid material output because there's no liquid material input. Alright, and third we have a cutter failure. So basically this is when the cutting tool on the lathe just shatters. It happens. But with that failure, both the outputs of the solid object as well as the solid particulate, aka chips, both of those outputs would fail. And for my final example, there's a few more, but I won't bore you to death. This would be a DRO failure. So basically, the divide section breaks. There's a broken fuse for the sensing system. Bad things happen. But the external power cannot be transferred to the sense either the sensors or the display, and all of the signals being passed along would also fail, thus failing the visual status as well. I will just slowly go through these so you can take a brief look. This is a jaw coupling failure. Basically, the jaws let go of the part. Here's a loss of human power input. So this is if, I don't know, the operator has a seizure while he is operating the lathe, and the failure gets passed down, and it could potentially break the tool. This is a motor failure, very similar to what happened in loss of external power. Loss of power to the motor, basically the exact opposite of the loss to the sensing system. Translational axis gearing failure, so basically if the gearing on the translational axes get gummed up or jammed or anything like that. Even though the failure would be passed through here, it wouldn't really affect the remove section because the tooling would be fine, the part would be fine, so technically it could still remove. It's just that system would not be called upon because the tool can't move, thus eliminating the possibility of a part or chips being able to come to be. Yep, so here is the last one, translational axis sensor failure. So that's just if the linear rail sensing just fails for whatever reason. Maybe coolant penetrated the housing of it and shorted it out. But that would cause a visual status failure, so the operator would not be able to know where he is or where his tool is. You always want to know where your tool is. Anyway, I hope this was entertaining and informative, and thank you. Thanks for watching.